So I wanted to check in and post explanation and screen recording regarding Lab 1. So this is Lab 1 for EXS 323 online class, and I just want to make sure that I go through a few of the principal things that are important to be aware of when we're doing these. It can be kind of difficult to do online labs, so to speak. So make sure if you have any questions or you need any help that you're communicating with me, and please don't wait till the last minute to try and conduct these labs, because they do, you guys especially, because we're not in the lab together and you can't just like ask me quick questions and get immediate answers. So it's important that you get started on some of these things, and then if you get stuck on calculations or some other aspect of the lab, you can we have time to kind of communicate regarding that. So the first thing that I want to point out is that in your Lab 1 in assignments, you click on assignments and then go to Lab 1. In Lab 1, you have your lab report guidelines. This is what I expect out of your lab reports. So you have 4 lab reports this term. So to be this week's experiments and next week's experiments get combined into one lab report that's due a week from next week, basically. So you have a couple weeks to finish your labs, but you are meant to be doing multiple experiments over different days to capture out in the field what we're trying to, the concepts that we're discussing in class. Okay, so the next thing you want to do is click on this online lab expectations and instructions for Lab 1. So that gets us to this document. Basically, there's a little blurb at the beginning here talking about what my expectations for the lab when it comes to online. So what I want, you don't want to make your experiment. You're going to be designing your own experiments to a certain extent. And the important thing to remember is that a good experiment is a simple and straightforward experiment that accurately captures the concepts that we're discussing and covering. And so I want to make sure that that's really clear, that I'm not expecting these to be super fancy. I'm not expecting them to be like way over the top. I just want them to be solid, thoughtful lab reports. Okay, so the lab report expectations are linked here. By the way, I have this in caps not because I'm yelling at everybody. I have this in caps because I just want to make sure that this is emphasized, that there are 4 lab write-ups through the term, and that each lab write-up will be the result of multiple weeks of experiments and data collection. And so I want to make sure that you're combining those. Sometimes the concepts are going to fit together nicely. Other times you'll have to work a little bit to tie them together, or you'll just say, for the first week we did this, for the second week we did that. Okay, so your lab expectations are very clear in terms of you need to have an introduction. One of the important parts about the introduction that I want to make sure that gets covered is that with the introduction, that you're tying concepts that we're talking about in class. So like this first experiment, we're going to be talking about work and manipulating work and the physiologic response to work. And so what you want to start to think about for your introduction would be something like being able to measure work, and the physiologic response of work is an important aspect of exercise physiology. It's important for fitness testing and other aspects of looking at people's physical fitness or their gains in fitness, something like that. And then you explain how you can manipulate work, look at physiologic response, and then you can tailor training programs or do different things to get, and then remeasure to get different outcomes. All right, so we want to play around with this concept of manipulating work and looking at the physiologic response to work a little bit, and that is the purpose of lab number 1. So moving down here, lab report number 1, there's some background about what you'll need and what you're going to set up in terms of your experiment. I want you to what the purpose of the lab is really to compare the physiologic response within two different exercise modes. And when I say modes, I mean things like walking on a treadmill versus stepping up and down on a bench. That's probably the most simple way we can do ergometry. You could also do like bench press versus squats or some other movement like that. But I want it to be about the workload, okay, and the work that you are producing. So let's walk through that a little bit. So one of the things that we're going to do is set up the experiments. I'm going to try and use this notepad to explain what I expect. So the experiments that you're going to be doing are, there is going to be mode 1, sorry for my handwriting, mode 1, work 1. Second condition is going to be mode 1, work 2. And the third condition you're going to do is mode 2, work 1. So in these two conditions, we're matching the work, but I'm expecting you to do different types of exercise. So mode 1 could equal step, and mode 2 could equal treadmill. So basically what I'm trying to get at here is that you do two different modes and match workload between conditions 1 and 3. But between conditions 1 and 2, so these conditions, what I'm expecting is that the mode is the same, but you alter things that alter work. So that's kind of the overall scheme of the experiment. So how could you do this? For example, if you chose bench step as your mode 1, okay? To measure the work in a bench step, there's examples in your book, and there's also examples in the write-up that I gave you over, whoops, how can I find that? Oh boy. There's examples in this write-up here. And so I'm just going to walk you through how to set that up. Okay, so you have a bench step, and let's say your bench step is 0.35 meters high, and then you step on it at a rate of 60 steps per minute. Now, in order to do this, you would actually need to, sorry, this is wrong. So 30 steps per minute. And that means each foot strike up, up, down, down, up, up, down, down would need to be done at 120 BPM. So you can download a metronome app on your iPhone or something like that, set it to 120 BPM. Every time it beeps, you take a step up or a step down. So up, up, down, down, up, up, down, down. Because we're only measuring vertical distance covered, then we're only going to measure the distance climbed. And so that would be at a rate of 30 steps per minute here. So say you did this for 5 minutes and an individual weighs 75 kilograms. Now you have weight, which we're going to use for our force calculation. We have time, rate, and the pace. So we know how many total steps we're going to take. If we take 30 steps per minute, then over 5 minutes, it's going to be 150 total steps. 150 times 0.35 is going to give you the total vertical distance, and that's part of how you calculate work. Remember, work is distance times force. Now, so distance is going to be the number of steps you take in 5 minutes multiplied by the height of the bench, and that's going to give you distance. For force, we're going to use our weight in kilograms, and we're also going to use, because we're traveling vertically, we're going to use gravity as our acceleration component, the acceleration of gravity, right? So you take 75 kg times 9.81, that equals force. So you take this force number here, multiply it by the vertical distance displaced, and that will give you work in joules. Again, all this, we've covered all this in the notes, and all these calculations are also on slides in the week 1 lecture notes. So make sure that you kind of take some time. You may have to pause this and look at it a couple times and go through it yourself. Like I said, I gave you all the numbers that you need, all the stuff you need for these calculations in the lab write-up description that I showed you just a second ago. So that would be your bench step. So this would be bench step, and this we'll call condition 1. Now, remember, condition 2 is going to be the same mode. Kind of look sure. It's going to be going to have bench step. It's going to be a different workload, though. So in order to change workload, we're going to manipulate something in here, or we want to manipulate the force, because we can manipulate either distance or force in order to change what the workload is. So for condition 2, we'll do bench step. Let's say we do 30 steps per minute, 120 beats per minute. But this time we'll do for 6 minutes, do body weight, so 75 kg, plus 5 kilogram of weight. So maybe you hold 2.5 kilogram dumbbells, and that's going to equal 5 kilograms of weight. And then you do this, and now you're going to have a condition 2 distance multiplied by a condition 2 force. And you're going to get a different amount of work because you altered aspects of work. And so it's going to equal a new calculation, right? Now, for both of these conditions, what you're going to want to do is measure heart rate every 30 seconds. Okay? So what we're doing now, heart rate is a physiologic parameter. And what we're going to look at is, what is your heart rate at 30 seconds, 60 seconds, 90 seconds, 120 seconds across this 5-minute period when you do a 0.35 meter bench step at 30 steps a minute for 5 minutes, and then what is the heart rate when we make these changes. And so what we're trying to demonstrate here is that when you change mechanical work, you require a different physiologic response, and it's important to be able to measure that and conduct one of these types of tests. And one of the reasons why it's important is because the bench step test is actually one of the easiest, least expensive, and accessible ways to do a general fitness test. So for example, if you want to be a personal trainer and you want a baseline physical fitness, you can put someone through a 5 or 10 minute bench step test and look at their average heart rate across that, and look at the rate at which their heart rate increases, and look at you can even measure things like rate of perceived exertion. So that RP would be, on a scale of 1 to 10, how hard was that? So that's perception, rate of perceived exertion, right? So you can measure all these different physiologic parameters, and then say you train for a couple weeks, you can do it again, and heart rate should be lower. So heart rate should be lower after a couple weeks of training if your training program is effective, or rate of perceived exertion should go down if your training rate is effective. So I hope this makes sense. I really want to be able to, you might have to watch this a couple times and like let it sink in a little bit, but I really want this process to seem intuitive to you and something that you could do on your own. And then I want to see that you can do it on your own. That's the whole purpose of this test. Now, when we're talking about these last, let me cover mode 1 versus mode 2. What I want to see here is that you do a different type of exercise than a bench step, but you match the total amount of work that you do. So, for example, in condition 1, if we do a 0.35 meter bench step at 30 steps per minute for 5 minutes, that's 150 steps. So if you take 150 steps times 0.35, that means the vertical distance is 52.5 meters. Okay. Now, because we're just using body weight, then body weight is what you're going to use for body weight is what you're going to use in this condition as well. So basically what we have to do is figure out a different type of exercise than a bench step that can raise your body weight a total of 52.5 meters, and look at the heart rate response to doing that same amount of work, climbing 52.5 meters, making your own body weight climb 52.5 meters, but doing a different type of exercise. So I'm going to erase all this and say that, for instance, mode 2, this is condition 3, mode 2 would be treadmill. Now, a treadmill, we're going to approximate a little bit here for the purpose of making the math easy. But if you set a treadmill at 100 meters per minute, that equals 3.7 miles per hour. So most treadmills you can set it at that. So 3.7 miles per hour, 100 meters per minute. Now, if I set this at a 3% grade at 100 meters per minute, that means every minute I'm going to rise 3 meters. Okay? So we know that we have to raise 52.5 meters. So if you take 52.5 meters and you divide that by 3 meters rise per minute, because we're walking, this is 3%. Every minute we increase 3 meters. So 3 meters per minute. Then meters will cancel out here, and 52.5 divided by 3 equals 17.5 minutes at 3.7 miles per hour at 3% grade. And that is going to equal the same work as condition 1. Now again, I'm throwing a lot of numbers at you and some calculations, but if you slow this down, kind of write all this out, it should make sense. Because basically what you're doing is you're saying, all right, well, instead of climbing 52.5 meters by going up a bench step, I'm going to climb 52.5 meters by walking on a treadmill at a 3% grade. At 100 meters per minute, it's going to take me 17 and a half minutes to do that, right? If you set it at a 6% grade, it would take you half this amount of time because you've doubled. Now you're going to be going up 6 meters per minute, okay? So then it would be 52.5 divided by 6, which would be half of what this is. Right? So 8.75 or something like that. Yeah, 8.75. Okay? So the idea here is that you are working with these numbers and that you're setting up a bench, that you're accessing a treadmill, that you're matching work across different treadmill, and then what you want to look at is your heart rate and your rate of perceived exertion in this condition. And what we want to know, for example, in your discussion is how is heart rate during a bench test to heart rate during a treadmill test when work is matched. And the question is, are they similar? Are they different? If they're similar, why would you think they'd be similar? If they're different, why would you think they'd be different? For example, do they use the same muscle groups? Are they using the same muscle groups in the same way? Are they? So that's the type of like critical analysis that I want to see in the discussion portion of your write-up. So your write-up should have an introduction in regards to this. You need to have a results section that talks about, or you need to have a method section that describes what you did. You need to have a results section that shows your work from all these calculations, and the results section should have charts and graphs. Do not turn in hand-drawn graphs. Make sure that you do your graphs in Excel. I can kind of, I'll show you guys how to do a typical graph in Excel here in a second, so that we're on the same page. You can also always Google or watch YouTube videos about how to make a graph in Excel. So I want to make sure that your results section has tables, graphs, and calculations. And then your discussion section is where you discuss the implications of those results. So why do you think you saw what you saw? Did your heart rate go up when the work went up? Did your heart rate go down if the workload was lower? Why do you think that is? All these different types of things that you can discuss within the context of the class and the material that we've covered so far in class. So I hope that starts to at least make a little bit of sense anyways. So one of the things I'll do real quick here is just give you guys an example of how to make a quick graph in Excel. So everybody with their Gmail account gets access to Google Sheets. I'm trying to open up a spreadsheet here. Okay. So quick kind of crash course in how to make a graph. So for example, if you did a 5-minute test and you took heart rate every 30 seconds, that'd be 30, 60, 90, 120, 150, 180, 210. Sorry, I can't count. 240, 300, no, every 30 seconds. I can count. 210, 240, 270, 300. Okay, so every 30 seconds for 5 minutes, you have heart rate for mode 1 condition, mode 1 work 1. This is mode 1 work 2, and this would be mode 2 work 1. Okay, so say you're at 80, 30 seconds in, and 90, then you kind of plateau, or sorry, then 100, 110, 120, then you stay at 120, for example. Now in mode 2, let's say you change weight, but you keep the length of time the same. But now it's a heavier load. So you start at 90, you go to 110, you go to 120, 125, 130, 135, and then you level off at 135. Right, so these would be heart rates every 30 seconds during the different conditions. And then let's just say this is when you're on the treadmill, you're doing the same amount of work, but let's say it's a little bit different than even though you're doing the same amount of work, you're doing it, I don't know, over a different amount of time, and your heart rate becomes a little different. Okay, so if you wanted to make a graph showing how your heart rate was displayed during those times, the thing you want to remember is that the far left hand, actually you want to move this up here. So the left hand column is going to be your x-axis. Your top column is those are going to be your conditions. So this is obviously the 3 different experiments that you did. And then the thing that you measure, which was heart rate, is going to go into the table, if you will. Right? And then all you have to do, it's quite simple. You just highlight this whole thing. You say insert a chart. And you turn this into a line chart. And voila, you have heart rate on the left-hand side. You have time on the right-hand side in seconds. And then the blue line is your first, so bench step workload 1. Bench step workload 2 was higher. And when you did the treadmill and match workloads, under these conditions, it would be higher than bench step workload 1, but lower than bench step workload 2. And if mechanical work was the only thing that dictated physiologic heart rate response, then these 2 lines should be the same, right? But these 2 lines are probably not going to be the same. And those are the types of things that you want to discuss in your discussion. Okay? So another thing would be, another graph that you could do for this lab, for example, is if you wanted to display average heart rates across the different conditions. So all you would do is take your data sheet here and say average, okay? And then equals average those, and then equals average these. And we can go to just H16. I'm just going to highlight the ones that we collected data on, H11 to H16. Okay, so now we have these different average heart rates. And again, you can put, but here to make a bar graph, it's a little bit different. We want to put I'm just copying that. We want to put our category, if you want to make a bar graph, you want to put your categories down the left-hand side. Because remember, the left-hand side is always on the x-axis. And when you make a bar graph, the left-hand side is on the x-axis. Then we'll put 110, 125, 112. That is the heart rates. You can highlight this whole thing and say insert chart and choose a bar graph. And now what we see is that mode 1, work 1, the average heart rate was 110. Mode 1, work 2, average heart rate was 125. Mode 2, work 1, heart rate was 112. Okay, so then you can just copy these and paste them into your results section, and you'll have a nice looking results section that gives you the basis of what you discuss in your discussion section. Strengths, weaknesses, limitations, things that you came across, thoughts that you had that relate back to class. That's how you would present this material. So I know that was a little bit long, potentially confusing at times. You may have to rewatch certain parts of it. But overall, it was just a summary explanation of exactly the type of calculation that I talk about in the Lab 1 example. And you should be able to follow this. And again, I'm not just having you do this because it's a waste of time or to check some box or something like that. This truly is an applicable thing to both illustrate how physiology changes as mechanical work changes. The other thing that's important is that I want you to be able to use these types of tests when you're doing fitness assessments and trying to understand gains from people that you may be working with or trying to track or those sorts of things. So I hope that makes sense. If you have any questions, please feel free to email me. Good luck as you start on this lab. I'll post a new lab next week and with some instructions. And if this is helpful, I'll continue to kind of upload these types of videos to make sure everybody's on the same page. And yeah, good luck and have fun with this.